Ever pondered what makes artificial intelligence so intelligent? It's all thanks to something called neural networks, the secret sauce that gives AI its adaptability and learning prowess. Picture a network of artificial neurons designed to mirror the inner workings of our own noggins. These networks are not static. They learn, they adapt, and they evolve, just like us. They sift through mountains of data, connecting the dots, identifying patterns, and making predictions. It's a complex dance of input and output, a digital ballet that takes place within the silicon confines of a computer. And this is just the tip of the iceberg. Neural networks are the backbone of AI, the hidden cogs turning behind the scenes, enabling machines to learn from their mistakes and improve over time. From voice recognition to predictive text, these networks are everywhere, silently shaping our digital world. Intrigued yet? Let's dive deeper into these neural networks. Imagine a super smart brain, but in digital form. That's a neural network for you. Neural networks are powerful computing systems that mimic the way our brains learn and process information. It's like having a mini brain inside your computer, crunching numbers and making sense of complex data. But how do these neural networks mimic the intricacies of the human brain? Well, a neural network is essentially a web of interconnected nodes or neurons, just like in our brains. These nodes are arranged in layers, each performing its specific function. The input layer is the first point of contact, receiving data from the outside world. This data can be anything: an image, a sound, a string of text, or a combination of these. The input layer processes this data and passes it on to the next layer, the hidden layer. The hidden layer is where the magic happens. It's called hidden, not because it's secretive, but because it's sandwiched between the input and output layers. Here, the data gets processed and transformed in complex ways. The output layer is the final stage, where the neural network makes its predictions based on the processed data. It's like the grand finale of a fireworks show, where all the pieces come together to create a stunning display, but the real beauty of a neural network lies in its ability to learn. Through a process known as training, the network adjusts its connections based on feedback, fine-tuning its predictions over time. It's like a child learning to walk, stumbling at first, but gradually improving with practice. So why does all this matter? Because neural networks are the heartbeat of artificial intelligence. They power everything from voice assistants on our phones to self-driving cars on our roads, and as we continue to refine and develop these systems, who knows what incredible feats they'll achieve next? Now that we know what a neural network is, how does it actually work? Stay tuned for the next scene to dive deeper into the fascinating mechanics of neural networks. Neural networks are like a relay race, with information being passed from one neuron to the next. Now let's break down this relay race and see how it actually works. First, we have the runners, or in our case, the neurons. These are the basic units of a neural network. Just like a runner receives the baton, processes the situation, and passes the baton to the next runner, a neuron receives input, processes it, and passes it on to the next neuron. The racetrack is made up of different sections, or layers. The first layer is the input layer, where the race begins. This is where the network receives all the data it needs to process. From there, the data is passed on to the hidden layers, where the real magic happens. These hidden layers are where the network learns to identify patterns and make predictions. Finally, we reach the output layer, the finish line, where the network provides the final result based on the processed data. Now, we can't expect our runners to be perfect from the get-go. They need training, and so do our neurons. During training, the network is fed a large amount of data, and the output is compared with the expected result. If there's a difference, the network adjusts its connections or weights to reduce this difference. This is done through a process called backpropagation. It's like a coach giving feedback to the runners, helping them improve their performance. Imagine this relay race happening millions of times with millions of neurons, and you get an idea of the complexity and power of neural networks. They are continuously learning and improving just like us. So we've got different neurons working together in a network, but did you know there are different types of these networks too? From recognizing faces to translating languages, different tasks require different types of neural networks. Delving into the world of neural networks, we find a variety of types, each with their own strengths. Two popular types include convolutional neural networks, or CNNs, and recurrent neural networks, or RNNs. CNNs are the go-to for tasks involving image recognition. Picture a system that excels in identifying patterns within visual data. much like how our eyes discern shapes and colors to recognize a familiar face. This is the realm of CNNs. Their structure is specifically designed to process pixel data, allowing them to handle images with a level of nuance and detail that other neural networks simply can't match. On the other hand, we have RNNs. These networks shine when dealing with sequential data like text or speech. Imagine reading a book or listening to a conversation. Understanding the meaning requires remembering the previous words in the sequence. That's what RNNs do. They have a form of memory that allows them to understand context and predict the next steps in a sequence. But what happens when we stack multiple layers of neurons? Welcome to the world of deep learning. In deep learning, we use complex structures with multiple layers to process data. This allows neural networks to tackle more complex problems with astounding accuracy and efficiency. In essence, deep learning is like a neural network on steroids. It takes the basic concept of a neural network and supercharges it, enabling it to learn from vast amounts of data and handle tasks of a complexity that would be impossible for simpler networks. These neural networks are not just fascinating, but they're changing the world as we know it. From powering the next generation of self-driving cars to revolutionizing healthcare with accurate and early diagnoses, the potential applications of neural networks are as vast as they are exciting. This is not just a field of study, it's a journey into the future, a peek into what's possible when we harness the power of artificial intelligence. Why should we care about neural networks? Because they're shaping our future. Neural networks aren't just a fascinating piece of technology, they're a game changer. They're the bridge between us and a future where machines can learn, adapt, and make decisions. They're paving the way for a world where artificial intelligence isn't just a concept, but a tangible reality that's transforming our lives. One of the most significant impacts of neural networks is in the healthcare sector. Imagine a world where doctors can diagnose diseases early and accurately, thanks to the power of AI. Neural networks can analyze vast amounts of medical data, spot patterns that humans might miss, and predict health issues before they become severe. The potential to revolutionize healthcare is immense, and we're only scratching the surface. In the realm of transportation, neural networks are fueling the dream of self-driving cars. They enable vehicles to recognize objects, understand their surroundings, and make decisions in real time. This could lead to safer roads, reduced traffic, and a more efficient transportation system. But the impact of neural networks extends beyond these sectors. They're being used to predict weather patterns, helping us prepare for natural disasters. They're aiding in language translation, breaking down barriers, and fostering global communication. They're even helping in wildlife conservation, analyzing animal behavior to protect endangered species. The beauty of neural networks lies in their versatility. They can be applied to virtually any field, providing insights and solutions that were once beyond our reach. And as they continue to evolve, their potential only grows. It's an exciting time to be alive, as we witness the dawn of a new era in technology. As we delve deeper into the world of neural networks, we unlock the door to limitless possibilities. Their impact is profound, and their potential boundless. So let's embrace this technology that's shaping our world. Let's harness its power, explore its potential, and marvel at its complexity. Because at the end of the day, it's not just about understanding neural networks, it's about using them to make our world a better place. The world of neural networks is vast and fascinating, offering unlimited possibilities for innovation and problem solving. We've taken a deep dive into the world of neural networks, but this is just the tip of the iceberg. From understanding what a neural network is, a computational model mirroring our brain's way of learning, to exploring how it works via interconnected layers of nodes or neurons, we've embarked on an enlightening journey. We've also touched upon the various types of neural networks, such as convolutional neural networks for image recognition, and recurrent neural networks for sequential data. Delving into the concept of deep learning, we've seen how stacking multiple layers of neurons allows for tackling complex problems with remarkable accuracy. But it doesn't stop there. The real magic lies in the impact of these networks. From revolutionizing healthcare to powering autonomous vehicles, they're shaping our future in unimaginable ways. Whether you're a tech wizard or a curious newbie, understanding neural networks helps us shape a world limited only by our imagination. Ready to continue the journey?